Okay, so we're going to talk about our test bed today and some of the parts. Now this video is for before you build. I know there's some groups that are skipping ahead. That's because they got done early with their mechanisms and whatnot. So this should be watched before we build. Now, you've got this PowerPoint here, which is located on the Google Classroom for you currently. And it's got tons of useful info because not only can you look at my example in class, but you've got this nice picture to show you, once you're done with this video, how to build the test bed. So utilize that instead of just relying on my test bed. So we're going to talk about some things here, what things are, how to tidy up your test bed, and some other little hints. Okay, so you'll have heard already from me that you want to have out a pencil and a piece of paper. One thing I'm going to tell you right away is that there's a couple things like the claw and the battery that I don't have on my test bed, and you are not going to have on yours either. Also, you'll notice that things like my potentiometer here is in a different spot. Not everything is located in the same spot. That's fine. You don't need it to all be the same as the picture. You just need to be on the bed and plugged in. Okay, so let's get going, and also pause the video when you need to take a note so that you don't have to scramble and miss something important. So what do we got? This page tells you a couple things. Number one, what is all on the test bed, and number two, where to plug everything in. So super useful once you get to the point of plugging in cords. So we've got motors, two motors, which are here and here. We've got a limit switch, which is this thing with the big metal piece sticking off of it right there. We've got a bumper switch, which is right there. We've got a green LED. A lot of people forget that. That's sitting back here, right here on the picture. We've got a line tracking sensor, which is right down here, the little screen on it, and the potentiometer. It's actually this red piece down here. It kind of gets covered in this picture by the gear. But basically you just need an axle in it and then a gear on top so you can turn back and forth. Okay, let's keep going. Now we're going to start talking about some of the parts, and you're going to have to pause during some of this and write down what I say. Please only write down what I say. You could write down more, but it would be a waste of time. Okay, so the first part is the VEX Cortex. Pause and write that down. And what that is the brain of the robot. I need you to write that it is the brain of the robot. It's where we plug in everything, our motors, our sensors. It's where we send the code to. This thing controls everything going on any robot you build. Okay, so the Cortex is the brain. Let's keep going. Next, we've got our two motors. Like I said, they're right here and here. We will eventually need to know that they're called 393 motors, but we don't need to write that down as of now. Write down VEX motors, and what's the important thing here is that they have to be turned on in a certain way. Okay? We need to give them a number, so we'll have to program a little number into them to tell them to turn. So let's say we wanted it to turn forward in full speed. Okay? Well, I would have to say, hey, robot, send the motor at 127, which means full forward. Okay, what if I wanted it to go full speed backwards? I would have to say, hey robot, send the motor at negative 127, and that would put it in full reverse. Okay, you can also do any number in between. 0 would obviously be standing still. Okay, so if you want half speed, it'd be around 63, so on and so forth. So write motors, and then what values they accept and what that means, and then let's move on. Okay, quick side note, you don't have to write this down, but it is good to know. The motor controllers, they plug in between the Cortex and the motor, so you'll notice the motor cord comes out, we hook it into this little cord, and that's all it is it's just a cord with a little box on it. It says motor controller, and that's what plugs in to the Cortex. What it's doing is switching the motor from a 2-wire motor to a 3-wire motor. Okay, and that gives us better control, allows us to do that full range of values. So that's why we do that. These are located in the box with all the other red parts, so make sure you get one of those when you are building, or two, one for each motor. Okay, we've got two sensors here, and before we really dive in here to what the sensors are, we need to talk about what digital means. Okay, so write down the word digital. And digital, what that means is put next to it yes or no. It's true or false, yes or no, 1 or 0. That's what digital is. In our case, our sensors, our digital sensors, either read 1 or 0. Okay? So for instance, if you push down on this little lever and you pressed it, we would see 1 show up on our screen. If you released it, you would see 0 show up on your screen. Okay? So we've got these two types of switches, limit switches, bumper switches, and they read 1 when they're pressed, 0 when they're not. So let's recap. We need to write down that the word digital means yes, no, true, false. Okay? We've got to write that we have two types of switches. We've got the limit switch, okay, write that one down, and bumper switch, this one here, and that they read 1 for pressed and 0 for released. Go ahead and pause and write that now. We've also got this VEX LED. This thing's really easy to use. It plugs into port 12 on digital here, and it is backwards here. It's supposed to be 1 will turn it on and 0 will turn it off. So once again, it's a true, false, yes, no type of thing. If you want to turn it on, you type in 1. If you want to turn it off, you type in 0. So put VEX LED, 1 equals on, 0 equals off. Write it down. Let's move on. Next is potentiometer. Please be careful with this. Okay, this is something that it's an analog sensor, and it only turns a certain amount. I'm going to start by saying that before I even talk about analog. It actually does have a starting and stopping point, and you'll notice that some of them have been mistreated over the years, and if you turn it too hard, you can actually go past the point where it's supposed to stop, which means it just continues to spin. That has happened to mine because it's been out and somebody was messing around, and what it does is it actually breaks it. It's not supposed to go farther than a certain degree. Okay, so please be careful with it. Don't turn it too far. Now, it's an analog sensor. Okay, so that means it's going to read a range of values. So go ahead and write down analog means it has a range of values. So that differs from the word digital. Digital is yes, no, 1, 0, true, false, whereas analog, it could be 0, it could be 20, it could be 600, it could be, there's a whole range of values there. Now, our potentiometer reads between the range of 0 and 4095, okay? And it'll read those values as it's being turned. So all the way one way, it'll read 0, and as you turn it up, it'll start to go up in number, until you get it all the way to the end, and it'll be sitting at 4095, okay? So you need to write that down. Potentiometer reads a range between 0 and 4095. Pause, write it, let's move on. Last but not least, our line tracking sensors. We've got these things. They've got the little screen on them. They send out an IR beam, infrared beam, and whatever's reflected back will determine its value. It is also an analog type sensor, so it also reads a range of values between 0 and 4095. Okay, so it shoots out a little beam until it hits something, and that beam bounces back, and if you haven't guessed already, it reads between light and dark, black and white. Okay, so if it's completely bright, I believe, so bright white would be closer to 0, and I believe darker is closer to 4095. And wherever you are in between there, if you have a gray, you would have something in between like a 2000. Okay, so go ahead, write down the line tracker, and that's a range between 0 and 4095. Now you've got everything you need. One last piece of advice here. We have a mess of cords on here. That's okay. We'll get that cleaned up. Just make sure you have everything plugged in correctly. Double check it to make sure that you don't have to go back, because it's really annoying once you start coding. The second thing, make sure if you've got a loose switch like me here, tighten that thing up. You don't want this stuff to move, okay? You want it to be down and sturdy. If it's sliding around on you, once again, you're going to have to go fix it eventually. Last but not least, a big thing that people overlook, that needs to be tightened, is the wheels. Okay, if they can fall right out like that on you, it's going to happen once you start the motors. So you need to find a way to stop that. I'll show you how I do it. I take one of these silver locking collars, easier to show you that one, and if you notice there's one right on the back side here, and it's kind of tricky to get in there, but you actually have to put it in first. I flip my whole test bed upside down, I drop in the locking collar, and then I sneak the axle through, and then I tighten it once I got it on the axle. So a little tricky, but get it on that back side right up against this metal piece here, the L-shaped one, and if you tighten that down, it'll block it from being pulled forward, and this thing will always be in your motor. Okay, so just a hint, the building part's pretty easy. Let me know if you have any questions. Neighbors are great resources as well. Once again, this PowerPoint is on the Google Classroom, so please use that for a picture. Let me know if there's any questions, and good luck, good building.